All right, here we go again with these literal equations. So I figured we just need more practice so they're not so scary. All right, this one here, we're trying to get h by itself. So let's see what's happening. On the side where the h is, all of this is smushed together, and there's nothing outside of what's smushed with the h to add or subtract away. So I know that I'll get rid of this stuff by dividing. But first, I need to deal with this fraction. So remember, when you don't see the number in front, it's understood to be a 1. So does everybody remember to get rid of a fraction that's multiplied with your variable? You multiply by the reciprocal. So if I flip 1/3 over, I get 3 over 1. So I'm going to multiply this side by 3 over 1, and I'm going to multiply this side by 3 over 1, which I'm just going to write as a 3. Okay, this is kind of messy, but 3 times v is 3v. You can't see my equal sign anymore, but it was right there. So when you multiply fractions, the numbers on the diagonal, if they're the same, they can cancel out. So the 3's going to go and the 1's going to go. Shoop, shoop. All I'm left with is pi r squared and the h. Okay, so now to get h by itself, all of these that are smushed with it, how do you think you're going to get rid of them if they're all smushed with it? You're going to divide, because things that are smushed are multiplied, and you get rid of multiplication with division. So I'm going to get rid of the pi by dividing, and I'm going to get rid of the r squared by dividing. And if I divide this side by pi r squared, I divide the left side by pi r squared. So pi divided by pi is 1, shoop. R squared divided by r squared is 1, shoop. All it leaves me is the h, which is what I wanted. I wanted h by itself, and then I can't actually divide these because they're not the same letter or anything, so I just recopy 3v over pi r squared. Is it pretty? No. Was it hard? Hopefully not. All I did was I got rid of a fraction by multiplying by the reciprocal, and the only other thing I did was I got rid of multiplication with division. That was it. I only did 2 things to this problem. All right, let's look at the next one. I'm trying to solve for a. So what do you notice about the a? There's one on the left and there's one on the right. We can't have that. We can only have one a if we want to solve for a. Okay, so I either need to move the negative 6a to this side or move the negative 8a to this side. Remember, I always like to move the smaller one, and a negative 8 is smaller than a negative 6. So I'm going to move the minus 8a by adding 8a to both sides. Remember, if you do it to one side, you have to do it to the other. So negative 6a plus 8a is a positive 2a. Bring down the positive 4b. Bring down the equals. Negative 8a plus 8a is 0. Shoop. And bring down the minus 2b. Okay, my goal is getting a by itself. So I have something smushed with it and something outside of that. So remember, whatever's outside of it, you need to zero that away. So to get rid of addition of 4b, I'm going to do the opposite and subtract 4b. That way 4b minus 4b is 0, and it's gone. Shoop. So my 2a comes down on the left. My equals comes down. Now can I combine those? I can. They're both b's. So negative 2b minus 4b makes a negative 6b. Okay, and then to get a by itself, how do you think you'll get rid of the 2? Divide. To undo multiplication, you divide. So I'm dividing both sides by 2. And that makes 1, so all I have left is a. And then I can actually divide these numbers. What's negative 6 divided by 2? Negative 3. And then the b just recopies. And that's my answer. Does it seem like it's getting any better? I hope so. All right, let's look at the next one. All right, I'm trying to solve for x. So whatever is smushed with the x or divided by it, we're going to save that for last. So to get rid of that addition of 8, I want to zero it out. How will I do it? I'm going to subtract it. So I'm going to subtract 8 from both sides. So 8 minus 8 is 0. That's gone. Bring down the x over a. Bring down the equals. Now, can you actually subtract these? No, they're not like terms. This has a b, this doesn't. So you can't do any math here. You're just recopying. So recopy the positive b and recopy the minus 8. No math involved. Okay, now remember there is a number in front of this x, you just don't see it, and it's a 1. So remember, to get rid of a fraction that's multiplied with the variable, you multiply by the reciprocal. So if I flip 1 over a over, I get a over 1. So I'm going to multiply this side by a over 1, and I'm going to multiply this whole side by a over 1. But a over 1 is just the same thing as a. But because there's 2 terms on this side, I need to put parentheses around it so that a gets distributed. Okay, on this side, the a's and the 1's get a cancel, shoop, shoop, leaving you Mr. X. And on this side, we need to distribute the a. So a times b, that just makes ab. And a times negative 8, that makes a negative 8a. And that's my answer. All right, let's look at the next one. Okay, my goal is to solve for x. All right, so I look at my problem. There's my x. There's only one of them. And I have something smushed with it and divided by it. So that's going to stay until the end. So whatever's outside of it, I need to get rid of it by zeroing it out. So to get rid of addition of b, I'm going to subtract b. So the 2x over a comes down. That equals comes down. And then can you subtract these? No. That has a d, that has a b. You can only add and subtract things if they're like terms. So no math here, just recopy. That's a positive d, and that's a minus b. So no math, just recopying. Now to get x by itself, any idea how I'm going to get rid of the 2 over a? Multiply by the reciprocal. So I'm going to multiply this side by a over 2. And because there's 2 terms over here, I'm going to put parentheses around it so I can multiply this whole side by a over 2. Okay, on the right side, the a's and 2's get to cancel out. Shoop, shoop, leave an x. And the left side, I need to distribute. Okay, so I'm taking a fraction times this d, so I'm just going to pop him over a 1. I'm taking this fraction times the b, so I'm going to pop it over 1. So let's take a over 2 times d over 1. Remember, you just multiply numerators and then denominators. So a times d is just ad. Put your fraction bar. And 2 times 1 is just 2. Okay, now let's do a over 2 times negative b. So multiply the numerators. So a times a negative b, a positive times a negative, that's just a negative. And a times b, that's just ab. Put your fraction bar. And denominators, 2 times 1, that's just 2. And that's our answer. And we're done. Okay, now this next one kind of looks like some others that we have seen in the past. Do you know what we've done to problems that look like this? We've turned them into proportions. I'm going to pop this whole side over a 1. And now I have a proportion. I have one fraction, an equal sign, and one fraction. So whenever you solve proportions, we cross multiply. So Mr. Butterfly, here you come. So 1 times x minus 2 is just x minus 2, because 1 times anything is whatever that anything is. Put your equal sign. Now let's multiply the other diagonal. Now this time it's a little different, because I need to take 2 times the m and the n. So I have to distribute the 2. I have to take 2 times the m, which is 2m, and 2 times the n, which is a positive 2n. So we had to do a little distributing there, because we're taking the 2 times the m plus n. So you distribute. That's what I just did there. Okay, so now I'm trying to solve for x. So there's nothing smushed or divided with the x this time, but there is subtraction to get rid of, to zero it out. So to get rid of subtraction, I add. So I'm going to add 2 to both sides. Negative 2 plus 2 is 0. Drop down the x, drop down the equals. Now let's look at this side. You think you can add any of that together? No, none of those are like terms. This has an m, this has an n, this doesn't even have a variable. So I can't do anything. There's no math to do. Just drop it all. Drop the positive 2m, drop the positive 2n, drop the positive 2. And that's it. That's all you can do. Okay, let's look at number 14. Do you think we could turn it into a proportion? Sure. If I pop this I over a 1, I've got myself a proportion. 1 fraction, equal sign, 1 fraction. And I solve them by cross multiplying. So I'm going to multiply this diagonal. So I times R, remember when you multiply letters, put them alphabetical? So it'd be IR. Put your equal sign. This is a 1 because everything's understood to be over 1. 1 times V, that's just V. Okay, so I'm trying to solve for R here. So to get R by itself, how do you think you get rid of the I? Divide. They're smushed. And smush is multiplication. And you get rid of multiplication with dividing. So I divide both sides by I. So that way, I divided by I is 1. So all you're left with is R. And then you can't actually divide those. So it just stays V divided by I. And that's it. That's the answer. Ooh, sorry, Mr. V. I cut into you. There we go. R equals V divided by I. All right, one last problem. What do you think you could do to this? You see 1 fraction over here. Let's make this a fraction. Pop it over a 1. Now we've got ourselves a proportion. So here we go. I'm going to cross multiply. I'm taking AB times E. Remember when you multiply letters, put them alphabetical? So to be ABE, they're all smushed together because when you multiply letters, they get smushed. So there's no addition or subtraction signs. Put your equal sign. Now let's multiply the other diagonal. 1 times C plus D. Well, 1 times anything is whatever that anything is. So 1 times C plus D is just C plus D. Okay, my goal is to solve for E here. So let's look on the side with the E. Notice these are all smushed with the E. So how are you going to get rid of the A and the B? Divide! We're going to divide both sides by A and by B. That way the A's and B's can cancel. Shoop, shoop, leave an E. Now, both of these are divided by AB. Let's see if we can reduce that piece or reduce that piece. Do you think you can do anything with C divided by AB? Nope. How about D divided by AB? Nope. Since I can't do either pieces, I'm going to do nothing. I'm just going to recopy it. C plus D over AB. And that's my answer. And that's all for this lesson. Smile